In this video, I'm going to talk about shadows of spheres using different views, and it's all in my book, Ellen's Guide to Casting Shadows on Amazon. The first step when finding the shadow of a sphere is to line up its different parts in the different views. So we have the front view, the side view, and the plan view. And you can see that the centers line up. The tangent points on the terminators line up. And you can see that they are connected by horizontal and vertical lines, all these green dots. The light rays go through the center of the sphere and are perpendicular to the terminator at that point, and that occurs in all the views. Here, too, the light ray is perpendicular to the terminator. And of course, the light rays are also tangent to the tangent points. I lined up these two views of a sphere, and a sphere always looks like a circle. So we have the center here, which is vertically above the center here, and tangent point 3 is above tangent point 4. Now, to find this elliptical shadow, you can see that the minor axis is as large as the diameter of the circle, and the major axis is determined by the light direction. So you could see that if the light direction were lower, then this shadow would be longer. And that's consistent with what we see outside. When the sun begins to set, shadows get longer. This method I call the point method. And we're looking at the front view and the side view, and we're trying to find this shadow. So you start with any point and find its shadow on the side view. Then, in both cases, you draw the light in the same direction. And for the side view, it's going to hit this wall and then bounce horizontally over like that. And where it intersects the light coming down from the front view would be number 4 on the shadow. And you can see here, this green dot is the same as this green dot. We have the two light directions going down like this, and then this one bounces off the wall and comes over here to intersect at point 5. This method I call from lines to circles. So we have a sphere in plan and elevation, and in both cases, a sphere will always look like a circle. We divide up the sphere into lines which represent circles that we're seeing head on. Let's take this red dot here. It goes down to this dot down here and then gets transferred over to the shadow that we're trying to find over here. And that will give us the red circle whose diameter is as long as this line. Now the black line here gets transferred over here to form the circle, the center of the circle here, and the diameter of this black circle is as long as this line. And then similarly, this line creates this light blue circle whose diameter is as long as this line. And then you just put an ellipse around all the circles and you've got the shadow. This again is the line to circle method, except this time the plan is on top of the elevation and the dividing line is horizontal. But it's the same concept. We start with the diameter of this circle. The center of that line gets transferred up like this following the light direction, and then it goes vertically up until it intersects a line going in the light direction through the middle of the sphere. And then we get this point here, and we know that this blue circle, its diameter, is as long as this line. Two other approaches are what I call circles to circles and ellipses to ellipses. So in this first one, we're looking down at the casting surface. So the object and its shadow are made up of circles. Now the red circle here is identical to the red circle in the shadow, and the center lines up with the light direction. The blue circle here is identical to this blue circle for the shadow, And again, its center lines up with the light direction. And then you just put an ellipse around all of these circles to get the elliptical shadow. Now for ellipses to ellipses, let's start with this ellipse on the sphere. We draw light rays tangent to its tips, and then it comes down to the shadow on the wall, and we can see that this ellipse is tangent to these light rays, and its center lines up with the center of this ellipse following the light direction. So again, this red one, the light direction is tangent to both ends of this ellipse, and it's tangent to the sides of this red elliptical shadow. And then you put a large ellipse over all the shadow ellipses. This shows you how to find the terminator of a sphere, going from circles to lines. So this first sphere, the green one, is made up of concentric circles. And the second one is made up of lines that represent vertical circles that we're seeing head on. And we know that they correlate because, for example, this red circle, if I could draw a straight line, would go to these two red lines that are the same size as this red circle. So draw the light direction in any manner, and then let's look at this green dot here on the green circle. We transfer it over until we run into the green line, and that will give us this dot. For the blue circle here, we transfer this over, and there's a blue line here, so we get this dot, and there's another blue line over here, so we get this dot. And then you connect them, and you have the terminator for the sphere. Please check out my book, Ellen's Guide to Casting Shadows, on Amazon, and please remember to subscribe.